Welcome to today's GibbsCAM video number 6. Today we are going to work on an MTM part, which means we're going to turn a part in the main spindle along with some milling and transfer it to the sub spindle, wherein we'll finish it off in the sub spindle and put it into the parts catcher. So the first thing, of course, we want to do is go to File, and we'll click on New, and we'll just call this MTM. And we'll save it, whatever folder you want. And it brings up a blank screen. First, make sure you are on the correct machine. In this case, we're going to do Morisiki DMG and LX 2500 SY. Now you can choose any other machine you want because we'll be programming it the same way, whether this was a Mazak, a Doosan, Kuma, Nakamura, just about any machine that you want with a main spindle, sub spindle, and a single turret. This is just a single turret tutorial, not a double turret. So first thing you want to do, of course, choose your machine, and we'll leave these blank for the moment. For main spindle, let's jump down to sub spindle. And for right now, let's just zero these out. And we'll go to no zoom, and you'll see, let's go to top view and no zoom. You'll see we have a main spindle, sub spindle, but we don't want to just work on the, have both of them there showing at the same time. Because you can see when I do a no zoom, it shows both of them. I just want to work on the main spindle right now, then we'll go work on the sub spindle by itself. So the first thing you usually want to do is go to the part stations and turn off the sub spindle just by clicking on the eye. Now when I click on no zoom, you'll see, you just see the main spindle now. So we'll work on the main spindle, then we'll work on the sub spindle, and then we'll do the rendering, and so on and so forth. So next we want to bring in our solid model. So let's just go to File and Import. And import, this is a SolidWorks file, so just open that. And we have our SolidWorks file into here. It's already in the right orientation. Now I want to get rid of these here. I'm not going to do feature recognition on this part. So what you do there is just go to View and you turn off the Show Hole Features. Okay. If you want to use feature recognition, then you could do this hole manager. It'll find all the holes and dimensions and everything else for you, but we're not going to do it in this tutorial. Now you also notice it's a little bit chunky there, and the reason being is I have my preferences set at 10 thousandths. So if I go to File, Preferences, you'll see it's set for 10 thou. This should be 1,000. So when you originally set up Gibbs, you should have the chord height at 1,000. So just to let you know that as well. But let's say, for instance, we brought in our solid and we want to change it. If you brought in a bunch of solids and you want to change them, just click on your solid there. If you have multiple solids, you can select them all. So let's just select our solid, right click, go to Show the Properties. If you had a number of solids there, you could go Show Properties of Selected. That would show them all. But we just have one part, so let's just go here. And right there, you can change it to 1,000ths. And 1,000ths is pretty good for just about every size part. So you can see that looks a lot better. That's one way to change it on the fly here if you've already brought in your solid model. But let's just show you if we went back to File and had our preferences already set to 1,000ths, click Apply. Now anytime I bring in a solid model, so import this again, you will see it's already nice and smooth and round, so everything looks pretty good. Now you always want to check the orientation of it, especially when you're doing milling. Like when I'm doing milling on here, I try to choose and rotate it to where the easiest it is to program. In this case, if I went to my coordinate systems and went to the YZ plane and I clicked on the home view, you can see this flat is parallel with the YZ plane, which is how I want it anyway, so that's good. So it's all oriented correctly. So let's just do modify and shrink wrap, usually what we do, and it shrinks material around the part. Now in the case of a square like this that has some corners on here, it's not going to necessarily find the outer dimensions of that. So I'm just going to go to Document Control, maybe go back to Main Spindle, and we're going to change this to 2.5 inches. And we'll look at that and see, yeah, that'll clear everything on our part there. So that looks pretty good. Okay, if we go to our document control again, by doing a shrink wrap, you can see this origin right here, our origin. If I go to a side view there, you can see it's back behind our part. And since we did a shrink wrap, it says it's 50 thousandths in front. The material is 50 thousandths in front of the origin. So I want to move the origin to the very front of our part because I want this to be Z0 when we machine it. So to change that, just go to Modify and down to Move Part Origin. Change the Z to 50 thou. Click on Do It. And you can see now our origin is right at the top there, and you can see it automatically changed the dimensions in here for us. So we have Z0 there. Now I want to do some, before I fill out the rest of this, I want to see what our material needs to be before we start doing any machining, before we start doing geometry or anything else. So we want to figure out all these dimensions. We can see it's 0.79 from the front to the back of the part right now. But of course we need to add material for this as well. So right now I want to add 1/8 of an inch of material on the front and maybe a little more on the back because my jaws are going to be sitting right around here, and that's not much to hold on to there. So we're going to have to add a little more stock to the back side. But as far as the front goes, let's add 1/8 of an inch there, and you can see there's our material, 1/8 of an inch. Now if I put in, that says 0.79, if I did minus 0.125, that makes it 0.915, kind of an odd size for a saw cut for material, so I'm just going to say minus 1 inch on there. So that'll give us plenty of room to grab onto there and machine. So next, before we fill in these two, I want to just pull the geometry off the part so we can do some measurements. So I'm going to click on the profiler right there where it says Slice Spun Body. That's going to give us a geometry that we need for machining, for turning. So I'll just click on the blue, the green area, it'll turn blue. Right click, click on Extract Profile, click on Do It, then you can turn off the profiler. And there's your geometry there to machine the part as far as turning goes. Now I want to add a few more dimensions here. This will make it easier to put in the correct dimensions on the sub spindle. So let's just bring our geometry palette up. Click on the point command, XYZ. So I want to put a point out here, 1/8 of an inch there, and this will make sense more when we go to the sub spindle. So I'm going to go up 1.25, and we'll just say 2.5 because that's the material I made it out here. This could be at 0, but we'll just keep it up here. It'll be easier to do dimensions. So click on the double point. So I have a point there now. I'm going to go minus 1 inch. Do a point there, and you can see that's at minus 1 inch there. Okay, now we can do some dimensioning here. So bring up your dimension palette. I'm going to choose this one right here. And we're going to click on this icon as well to make sure it stays open. So I want to put a dimension from here to probably right here. That's probably where we want to grab with the sub spindle right before the radius on there. So I'll put that there. Okay, next I'm going to put a dimension from here. Just click in space to unselect that there. So I want to click right here and probably about right here for where the jaws are going to grab. Remember, we'll have material there. And I want of course the tool when we're roughing and milling to go a little bit past this flange here, but not run into the jaws. So right there is good. Now from the back of our part to the front of the part, of course, is 0.895 there. Let's bring this out a little bit there. Actually, that's not the one we want, so we can delete that. I want to go right from here actually to here. So that's 1.250. Let's get these dimensions a little bit centered there, a little bit better. And then I believe the last dimension we probably need is from here to where the actual jaw is going to be grabbing, right here, 0.895. And I think that's all the dimensions we really need for right now. This will make more sense when we go to the sub spindle on telling Gibbs how much material is sticking out. So everything looks pretty good right there. Okay, So let's bring in our tool list. So I haven't created a tool list yet, but let's just import our tool list into here. So we're just going to go to space number 1, just right click, go to load tools, and this is our tool list for class 6. And this will be on the YouTube page as well. You can download this list if you'd like. But here's all the tools now. Let's just go through all the tools. This is going to be an 80-degree diamond, CNMG, 32nd, half-inch IC or inscribed diameter, 1/8 inch thickness. This could be 3/16 as well, whatever you would like there. And it's in station number 1, and you can see it right here. The length out is 6 inches. I think I want to change that to 4 though. And I always give it a name on here, so when we put the code out on the machine, the operator can see exactly what this tool is supposed to be doing. So I just put main spindle, rough face, and OD. And this is, of course, offset number 1, X positive side. And we want the insert facing backwards. We don't want to click on insert face up because that's an M4. That'll force the chips into the operator or the front of the machine. We want the chips to stay at the back of the machine. So that's why I have it sitting in this direction. Let's look at tool number 2. This is just a drill going through the part. I have 175 degrees, so it's almost flat. So if you have an inserted drill, you could do that, or a carbide saw, whatever you would like to do for this. And of course, give it a name, main spindle drilling. I have length out of holder 3, tool length offset 2. This should also be 2. Just clarify that. This is going to be the boring bar here. So this is a 64th tool nose radius, 1/4 inch IC, station number 3. Now I don't know if I want that small of a boring bar. You can choose that. You can see minimum bore is 600 there. I haven't dimensioned the bore yet. Let's put in a dimension there just so we know what that actually is. So we'll put this bore right there. That's 3/4 of an inch. So this is 600, so that's probably okay. 600. If we go bigger than the actual part size, then Gibbs will not let the tool go inside there. So this looks pretty good. We'll keep that there. Next tool is a 55-degree holder. We'll change this to 4 inches as well. And a 64th radius, IC 3/8, 5/32, station number 4, offset 4, so make sure all this matches. X plus. This is going to be the holes in here. This is going to be, of course, a spot drill first in position number 5, 1/4 inch, 2 flute. Then we have our 1/4 inch end mill to do the counter bores, and 1/8 of an inch for the holes in there, and 1/2 inch to cut the periphery of the hexagon there with the square with the corners. And then the rest of these are for the sub spindle. This is going to be also a CNMG 80-degree diamond. It's in for the sub spindle. We'll change this to 4 inches as well. And this is going to be offset number 17. So we're adding 16 to this to make an offset 17. Now you can change this to whatever you want. Depends on your machine manufacturer what the sub spindle tool will be, but just make sure this offset matches the sub spindle for the backside tool. You wouldn't want to give this position offset number 1 as well, because we already have that up here at the top. So this has to be a different offset, but it's going to be in the same turret location, position number 1. Okay, next one is going to be a boring bar to finish off the back side. As you can see, we have backside boring that needs to be done as well. We'll just unzoom this and go to home view there. And again, give it a name there. And of course, 55-degree on the back side. That's going to be in position number 4, same as up here, but a different offset. So I chose offset 20. And then, of course, a 1/2 inch there to finish off the back side there. And I think we have all the tools we need there. So let's unzoom this. Home view, unzoom. Now let's open up our document control, fill in a few blanks here. Main spindle, 2.5, this is correct, all here. Now we need to figure out how much material is sticking out of the jaws from when we grab it on our main jaws here. And as you can see, since we dimensioned it, we're going to grab right here with our jaws. Dimension 895 is sticking out from our jaws on the main spindle to our stock. So right here, put in 0.895. Okay. Now it needs to know also how much is actually in the jaws there. As you can see from right here where our jaws are going to be to the back is 0.230. So I'm going to change that to 0.230. All right, that's good for everything's there, perfect. So we have diameter we want to program, of course, in inches. We don't want to program millimeters, we're in inches. And we have 2.5 inch stock, 2.6 will give us enough clearance for this. You can always go bigger, it's up to you. And instead of 0.2, I'm going to round this off to 1/4 inch there. And initial stock means it's already loaded in the spindle when you press cycle start, and preloaded. Okay, so it's all ready to go. And this graphic part face distance right here, I'm just going to put 10 inches in there. Now what this means, let me just show you what that means there. We'll put 10 inches in there. Let me turn on the sub spindle just for a moment. One there. Now if I go to no zoom, you can see that's approximately 10 inches there on our screen. Now if I put what the actual machine is, which is around, let's just say 25 inches there, if I do that, when I do a no zoom, you can see how much space there is between the two. So you're always having to zoom this up and work on that and zoom up the sub spindle. And so it just makes it easier. The programming will still be the same. Your G-code output will be the same no matter what you have in here. This is just the distance that you see on your screen between the two spindles. So that keeps you from having to pan main spindle, sub spindle. So let's just put about 10 inches in there. That's usually about what I do most of the time. And no zoom, and you can see now the spindles are a lot closer together. So when you do rendering, it's easy to see the two spindles without having to do a lot of panning. So let's turn off sub spindle for the moment. So we're going to just program the main spindle right now. I'm going to turn off dimensions. Okay, I'm going to turn on my cam. So the first thing I want to do is, of course, face this off. So I'm going to put in, just double click this process, put in a roughing process there with tool number 1. We're going to do a front face. This is our clearance values before we cut, clearance before we go back home or do the next operation. And we have an 1/8 of an inch material to face off here. I'm going to say cut depth 50 thou there. We're cutting forward, front face, all that looks pretty good. XR stock, really don't need anything there, but Z stock, I'm going to leave 3 thou there for the finish pass on here. Now, depending on the material, you can click on the material, speed, RPM, and feed. And of course, depends on your material. We chose, as far as the material goes, aluminum alloys, so you can, of course, change whatever material you'd like there. And since we're facing it off, I'm probably going to do constant surface speed, and we'll click on, figure that out, surface speed 8,000, which is a little fast. And since it's aluminum, you'd probably be okay, but let's just change this. I'll show you how to change this. So let's go to the material. And this is the material database. Let's modify that database. Let's say surface feet per minute is suggested 8,000. That's a little faster than I want to go. I'm going to say, let's change this instead of 8,000. Let's change it to 2,000. 6 is okay for right now. So we just modified the tool database now. Material database. So let's just do surface feet per minute. You can see now it's 2,000 surface feet per minute. Entry is 6 and contour 6. Since we're roughing, that's a little slow, so I'm going to actually input 12 thou there. Both of those, since we're just roughing. I want a can cycle, so make sure you have that on. Coolant on, flood coolant on. Everything else there, ZX plane, is all good. Okay. So let's click on this front face right here. This is what we want to finish. You can drag this marker to above your stock, or you can right click and say move to whatever you'd like to put in there. It's up to you. If you want it a certain distance away, that's up to you. Of course, arrow down, we want to face from the top down. And we want to put the black round one close to X0, Z0. Just don't go below it. If you want, you can put a point there and just have it snap there. And you can also right click and say, I want to move it to The endpoint, maybe you want to move it to right to 0. That's up to you. That'll put it right at 0. And then click on Do It. So there's our toolpath there. If we want to render, we can render right at the same time. Slow it down. And so you can see, looks pretty good so far. Now we're using the same tool to cut the OD, so I'm just going to, so we chose OD. Remember, we have our clearance at 2.6 is fine. This is the material, 2.5 inch. This time I'm going to say cut depth of 1/8 of an inch is just fine. XR stock, I want to leave some stock to finish, so that'll be 10 thou per XR radial value, so 20 thousandths overall. Everything else there looks pretty good. Can cycle, all that looks good there. So I'm going to click on this radius to start out with, start outside of our part a little bit. And the easiest way is just hold Control and Shift, click on the last feature you want to cut, and we'll go a little bit past there. We don't want to go into our jaws. Remember, our jaws are right here, so we don't want to go too far past that. Click on Do It. Now we have our roughing finished out. Okay, let's clear this. Now we want to drill this before we finish the outside because of stress relief. So this time we want to do holes, and this is not live tool, this is a static, so hole, and with our 0.688 drill. Okay, front face. We had our clearance set at 0.250, so I'm going to keep it there. And we faced almost everything off. There's 3 thou there, but we can have 3 thou in there or 0. It doesn't matter. Either one's good. Let's click on this button right here, and you can see the line goes down to the edge or the chamfer on the actual drill there. And we'll hold the Alt key down and click on there. Remember, that was 1 inch. So that's right to the stock there. We want to go a little bit past, so I'm going to say minus 1.1. Okay, again, we can put in our RPM feed rate there. Pretty good. Can cycle, everything just feed in, wrap it out. You could choose PEC in that, but if you have high pressure on right here, then you really don't need to PEC. You can just blow through there. So let's click on Do It. All right. Next, we want to bore this out, rough bore it. So we're going to clear this out, put in a roughing with our boring bar. You can just hover over these. It'll show you the tools there. That's our boring bar for the main spindle. This time it's a front ID, okay? And since our drill is a 0.688 that we went through there on, then we can use that tool. So 0.687 is just fine. Where we're going to wrap it to, and when we're done, and this is the material basically that was left from our drill. I don't know if I want to go 1/8 of an inch there. Let's go 60 thou there per side. 12 thou. A little fast for that small of an insert. We'll stay at 6 thou, which is good. Prefer canned. Stock and Z is just fine. All that looks pretty good there. Okay, so let's click on the bore there. And we want to start outside our part there. We're going from the right to the left. And our black one to the end of our part, a little bit past it, so we'll make sure the bore goes clear through it. Click on Do It. Then we have a couple of passes in there, not too many there. Okay, now we want to, since we've roughed everything out, at least on the front side, now let's finish it. So let's clear this out. Let's double click, do a contour with that same boring bar. Front ID, about the same place we want to wrap it to, main spindle, 90-degree line there, so we'll come off there, which is fine. Entry and speed, all this looks really good there. Okay, I think everything looks good there. Let's just move our markers around. Start off our part, that direction. And we actually just really need to finish here because on the back side we'll cut all this out. So let's do it there. So one thing I need to choose though is the cut on the inside, not the outside. So we'll, instead of deleting this, just click on redo. That'll redo that toolpath there. Okay, so all that looks pretty good so far. Let's do a rendering, see where we're at. Let me slow it down and start over. Face. Now we're roughing the OD. And of course drill. Let's show you a cutaway view there. And bore and finish bore. So far so good. Okay, let's finish the outside now since we finished the ID. So we can leave contour in there. Let's just open that up. And let's, of course, bring our tool down. You can just drag and drop a tool on top of there. That's tool number 4. We're going to do a OD. Now I don't want to start at 2.6 up here and then feed all the way down here. So we know our bore is 0.688, so let's just wrap it to 0.6 there. So the tool is going to wrap it to 0.6 before it starts going in to cut. We have a 50th thou line in there before we start cutting. Entry feed, and all this looks good. No stock there. Okay, click in space. I'm going to start right here. Zoom up a little bit lower than our bore, that direction. Again, I'm going to hold the Control and Shift. Click on this last line here, and just a little bit past there, and click on Do It. Now we should have a finish pass there for our part for the OD. So there we go. And that looks good. So everything on the front side has been all machined as far as the turning goes. Now we need to do some of the milling. So let's just go back to isometric view. And I'm going to give it a new work group. So this work group was the original one. I'm just going to call this turning. I'll turn on caps there. A little easier to see. So this is the turning. I'm going to separate the turning and the milling so it's easier to choose what we want to cut. So I'm going to click on new work group and call this milling. And if you want, you could put turning main, milling main, and then turning sub, but we'll just keep these two here for right now. So now we have another work group. As you can see, the geometry is gone for the turning portion of it. Let's turn off our cam because we need to bring up some geometry. I'll turn off tools while we're at it. And since the tools are coming from the face, I need to change my coordinate system to the XY plane. As you can see, that changes right there. Now we can extract geometry, or we can use a profiler, or a combination of both. But let's just do face selection right now. Let's just click on this face right here. Looks like we have a little radius in there, so which is okay. So I'll probably use the profiler instead so I don't cut it undersized when I'm milling. So let's just go to the profiler. You can see the profiler, drag it. I'm going to drag it about down to here. You can always right click and go profiler depth and give it a depth, but this is good enough as long as it's off the radius there. And since this is a pretty good part, I'm just going to do polar and cylindrical, so it'll rotate each hole there. So I only need to extract this hole for right now. It'll give me that one. And I really don't need to do this one other than to get measurements off there. So while we're at it, we'll just drag it through there. And it'll extract that geometry there. And maybe while I'm there, we'll just do the back there. And we'll just click this hole right here. That's good. And while I'm here, I might as well get the square with the corners. So just click that, extract that. Now we can turn off the profiler. Now you can see I have pretty much everything I need to cut that front side there. If you want, you can move all these out to Z0 or the depth you want. That's up to you, but we really don't need to for this part. Okay, so let's open up our tools and cam. Let's clear out the first process. And then we want to do, first thing we want to do is a milling process. We can't really drill on these angles with this radius here. It'll deflect the tool. So we have to do some end milling first before we do any drilling. So to do that, let's create a process, a drilling process with the 1/4 inch end mill. Scroll down, find our 1/4 inch end mill. We can't interpolate these because the counterbore is 1/4 inch and our tool is a 1/4 inch. So we're going to use a drilling process, and we're going to, instead of feed in and wrap it out, we're going to do a peck with a full out. Since it's an end mill, we need to clear the chips here, so we're going to do a peck with a full out, RPM and feed rate. Don't need a dwell clearance. I'm going to go 10,000. When it comes back in, it's going to be 10 thousandths away from the last cut it took, and then go in again. So we're going to do a peck of 80 thousandths, and we're going to stay at 0.1 rapid. Let's just look at the clearance here. We could get a little closer, but we're going to stay 0.1 away. We could adjust that if we need to. The mount we're going to, or the surface, the material we're going to start cutting at, I'm going to say it's minus 0.1. We're just going to guess right there for now. 0.1 there, and the depth. So highlight the depth, hold the Alt key down, click on the face that we want to go to, which is minus 0.27. And we don't need this. And part clearance, we could probably stay at the R level 0.1, and we're probably really good right there. So let's go to the rotate tab. First, make sure we're on the right plane, which we are, XY plane. And we're going to do polar and cylindrical because I don't know if our machine has enough clearance to keep this locked with a brake on and go around each station here. So we're going to do polar and cylindrical. And we have 1, 2, 3, 4, 5, 6 slots. So I want to do it 5 more times because we already are doing the first one. And to get the angle, we could just type in 360 divided by 6. And of course, that will be 60 degrees. And we'll click on, you can click on either this one or this one. Since we're doing a drilling cycle, Gibbs doesn't care which circle you really pick. And let's click on do it. And now we have our polar and cylindrical around the part there, and then we can stop and take a look. So if we go to our rendering, and we'll turn off geometry there, and click on play. Let's have our facing, of course. Drill, finish, finish. Now we're going to do the counter bore. And it looks pretty good there. So our counter bores are done. Let's go back to ISO view. Next, we're going to do a spot drill because we need, now that we have the flats on here, we need to do a spot before we let the drill go in there. So we're doing still a drilling process, but let's do with a 1/4 inch spot drill. And again, this time we're going to wrap it a little bit closer down to the hole. So I'm going to Alt click the hole there. That's minus 0.27. We don't want to go rapid to there, but we want to be able to clear this radius here. And since these holes through the part are 1/8 of an inch, we just want to spot drill them to take a little chamfer on there so we don't have a burr there. So we're at minus 0.27. So in this diameter right here, we tell Gibbs what we want that tool to cut. So we have a 125. So if I put 135, it'll adjust the depth automatically for us. If we go to the rotate tab, everything there is good. Check our RPM. Probably really don't need to go that fast for a spot drill. So let's just go 2010 there. And we don't want to do a peck. We'll just do a feed in, wrap it out. Everything there looks good. Let's just click on there. Click on the actual geometry there. Click on do it. Then let's take a render there and let's see how our spot drilling is going. So there. So spot drilling looks good. Now the next thing you want to do, of course, is drill through the part. So we use the 1/8 inch drill, just drag and drop. And everything there is pretty good here. We want to go clear through the part though, at least to the back side there. So if we rotate our part a little bit, at least to this surface here. So I'm going to highlight this box right here, hold the Alt key down and click that surface there. We can see it's minus 0.36. We'll just barely get us through there. I want to go a little bit more, so minus 0.370. And this time we'll do feed in, wrap it out. Be pretty good with high pressure. That should work very well. Okay, again, we'll highlight this hole here and click on do it. And if we render, we'll see now we have the 1/8 inch holes through there. with a little bit of chamfer on there, you'll see. So we don't have the burrs on there. So far, so good. Now the next thing we want to do, of course, is cut the flange and drill the holes through there. So this is what we have so far. Now we need to drill the holes on the flange out here. This is using the same spot drill and the same drill through there, also an 1/8 of an inch there. So let's take let's clear this out. Let's do our spot drill. So drill and our spot drill there. And again, we're going to wrap it a little bit closer to this flange. So I'm just going to hold down the Alt key. That's minus 0.547. I'm going to say minus 0.5. And this will be minus 0.547 because that's the surface we're starting from. And here, 1/8 of an inch hole goes through. So I'm going to put 135 as well for the 1/8 inch. Everything there else looks pretty good. But let's go to the Rotate tab. Now this time we just need to do 3 more holes because we were already doing the 1 hole there. So we just have 3 left here. And each one is going to be 90 degrees. And if we click on the first hole there and click on Do It, then we'll have the 4 holes through there. Now let's look a little bit. I want to rapid to all the way out to do each hole. I want to get a little bit closer so we're not wasting so much time. So what I need to do here is change this because right now it's doing 1 hole, rapiding to 0.1, going to the next hole, rapiding closer in, then back down. We could just stay at that level here, so I'm going to say right here, minus 0.5. Let's redo that. Now you can see the first hole rapids to here at 1/2 inch, then it spots, and it stays at that minus 1/2 inch. Go to the next hole, next hole. This is the last hole, then it's going to, of course, come out. So if we render this, we're going to see exactly that. I'll stop it when it gets a little closer. Okay, now we'll slow this down. You can see it's staying at the minus 0.5 inch level, so it saves us a little bit of time there. Okay, next we want to drill, of course, the 1/8 inch drill through the part. So let's just take the 1/8 inch, drag it down through there. Again, everything there looks pretty good except for the depth there. So we're at 547. We'll just double click, Alt click this face, 547. But over here, I want to cut to this flange right here, the back of the flange, 0.7, minus 0.7. I'm going to round that off to minus 0.750 to make sure it gets through there. Click on the hole. Click on Redo, or Do It, depending on what you selected there. Now we have our hole through the part, so let's render this so far, see where we're at. We'll speed it up. And we have our holes through there. Looks good. Okay, so the next thing we want to do now, just go back to ISO view, is to cut the flange here. So let's clear anything out here, put in a contour with our 1/2 inch end mill here. Now I want to wrap it to 0.1, which is fine. We could wrap it a little bit closer in, but that's okay. I want to stay here and kind of feed in on here so we're not rapiding in. And of course, Alt click this surface. It's minus 0.547. And 3/4, we could also Alt click if you want the back here, and you can see it's minus 0.7. I'm going to round it off to minus 0.750, which will stay away from our jaws that is holding on the back side there as well. Of course, adjust your RPM and feed rate. We want to do an entry and a 90-degree line there. I want cutter radius comp on in case I want to comp for the size, depending on how accurate I want this to cut. Round corners of a 10th break on all the corners. That way we won't leave a burr on the corners there. That'll be good. I probably want to do maybe 3 extra steps, and we'll say, so normally this is set at 0. You can see that's the normal. But we want to do probably 3 extra steps there, and we'll say 1/8 of an inch per step. I want to leave stock on the whole thing. Now if you want, you can go to the home view there, and I want to start on this side, so it's kind of on the above the X side of the part. Click there. Of course, we want a climb mill, cut on the outside. Going to click on Do It. There's our toolpath. Let's render the C if this is how we want to do it, or adjust anything. So we'll go to here, and I'm going to click on the stop sign here and say stop before operation 12, which is this one here. So we'll speed everything up. We'll just rewind it, speed everything up. Now it's stopping, so it's going to go to operation 12 now. So we'll see if this catches our part there. Not quite, so we could probably reduce that to maybe 2. So let's go back here. Let's turn this off. Let's go back to maybe 2 extra offsets. Let's look at the rotate tab. We want to do polar and cylindrical, of course, and we'll click on redo. Now let's take a look at it. We'll fast forward to that operation. And again, let's look and see how it looks. Arc in. Okay, so far so good. Speed it up. Now our next cut. Next cut. And looks good. That roughed it out. Now we need to, of course, let's take a finish pass on here. Again with a contour. Just choose an empty tile over here with the same thing, just a contour. This time we're going to put 0 there. And we're going to 0 out the stock there. And everything there is still the same, so we'll just click on Do It. And now this should be our finish pass here. We'll speed this up again to the end. And let's this go a little bit faster as well. So there's our rough, and our next rough, and our next rough, and then 10th thou to finish. And everything there looks pretty good. Now this finishes part 1 of part 2, but a few things we can do here to speed things up so we're not rotating the turret more than a couple of times to use the same tool. So you can see we have tool number 6, which is the 1/4 inch end mill, which is fine. Tool number 5, which is the spot drill. Then we go back to tool number 7, then back to tool number 5. Well, tool number 7 is the 1/8 inch drill. So let's move the spot drill up between these two. So just drag it, put it between that little triangle. So now we have tool number 6, which is the end mill, then our spot drill, then spot drill, and then we're going to take the 1/8 inch drill and drill and drill. So that way we don't have to go and change the turret a number of times. So if we render this again one last time, turning. Okay, now we have our end mill. Now we're going to spot, and then at the same time spot the outside, then drill, then drill. So the next thing on part number 2 will be, of course, to transfer it to the sub spindle and finish this off. But this concludes part 1 of this MTM part number 4. So thanks for watching.